Hi. So this is a re-recording of one of my talks which I gave just yesterday at the BangPypers Python meetup. There were some technical glitches, so I decided to re-record the entire thing. But yeah, I'm trying to expand upon the talk as well. So this might be a little longer than. So the title of the talk is Explicit is Better Than Implicit, and it's essentially a version of Rust for Pythonists. Hi, I'm Vinay Kirti. I go by Stonecharioteer everywhere. I also blog and sometimes I write long form articles at stonecharioteer.com. I'm a self-taught developer and I have been using Python for about 8 years. I mostly build web applications. I write command line tools and once or twice the odd GUI. And sometimes I also automate pipelines. Currently, I work in the data engineering team at Merkle Science, cryptocurrency analytics firm. Before this, I used to work at Visa, GK and Driveline, and Flipkart. Fair warning, I've only started using Rust around 30 days ago. So it's not like I'm an expert, but this is just my point of view as someone who has been using Rust for 30 and someone who has been only coding in Python, mostly only coding in Python for almost 8 years. So this is how I perceive my. So what's with the title? If you go back to this, if you've ever run this command, at least just this command, and you look at the fourth line, you will get this statement. Explicit is better than implicit. This is the fourth line of the Zen of Python. And what it says is, it essentially means if you're writing code, it is always better that your code uh, explicitly says what is going to happen rather than it being implied. This is very true, especially for code which seems to have a lot of magic going behind it. It's also one of the reasons why, like, at some points of time, I prefer, I like to tell people that I prefer Flask or Django, for example, because, and I'm well known for saying this, because in my point of view, if your code is able to explicitly say what is happening and you're in control of all of that, it seems much more, it seems a far better. Granted, there are moments where Django is a superior choice of framework for your work. However, that's the Zen of Python. Explicit is indeed better than is indeed better than implicit. Now, Rust embodies this fact to a fault. What it does is it makes you write code in such a way that you are explicit about everything, and that's what I liked about Rust. I gravitated towards Rust for this single reason. What does this talk about? Again, this is not a Rust tutorial. This is more like a my journey, Stonecharioteer's journey towards Rust. I already know about Python, and I wanted to explain how my journey learning uh, what is essentially a systems programming language. Well, Rust doesn't follow that tag anymore, but still, what is essentially something in the space of C++, C, or any of those other languages? How do I, as someone who's been learning computer science only by my own efforts and not through a formal education system, how do I feel about Rust? So this is that journey, and these are the topics I will be covering. First, why Rust? Like I've been saying, I've been writing only Python code my entire life. I wanted to try something new. I had tried some Golang resources, and while I liked several of what the tutorials promised, I there was somewhere where I felt like at the back of my head, it always felt like Rust was the thing I needed to adopt. And I'd first heard about Rust a few years ago on Hacker News, and these are all the things I knew when I got into Rust. I knew that Rust is really fast. Rust has a very steep learning curve. It's low level. It's got something called the borrow checker. And I'd also heard a lot of things about how strings are weird. Uh, uh, Full admission, before I'd even tried writing something, I've gone through several Rust tutorials over the past. I tried reading the Rust book. I tried reading Rust by example. I tried doing the Rust Links course before. I tried some YouTube videos. I tried getting into Rust several times over the past few years. However, it's only in the last 30 days, 40 days right now that I actually feel like I'm finally able to use Rust to do something. This is saying a lot because the last 30 to 40 days, I have not written any Python. For my job, I've only been writing Rust. This is saying a lot. So you might think, I already know Python. And in my opinion, that's very good. Python helps you solve problems. If it helps you solve problems quickly, you should stick with that. It can do almost anything you want. Even if you need scale, you need to think about distributing your problems horizontally. You need to think about distributing your problems, your tasks across workers. Use Celery. Use uh, there are there are other ways you can do it through multiprocessing. You can use some, even in Flask. You can use the background scheduler, the Flask scheduler. You can use so many other things just to distribute your tasks across systems. Like Dask, for example, was built for this. And you can also leverage other libraries. Like instead of using native data types, you can also switch over to Pandas, NumPy, SciPy, and all these other libraries which come with their own data types. These data types are written, these libraries themselves are written in C, and they're extremely performant over the native types. And if you want, you can also try using something like Python or PyCuda to write faster code. And if you're braver, you can try switching over your Python installation itself. It's the regular Python installation that most people use. It's called C Python. Again, it's called C Python, not Python. They're two different things. So C Python is, while it's the most widely adopted version of Python, there are other versions, of which PyPy is really, really fast. So sometimes just switching over to PyPy gives you a very good improvement. That being said, you should. The reason why I go around exploring languages and why I want to learn programming languages in general is because I would like to understand different paradigms. Staying in one language and becoming really good at it, while that's a great thing to do, it also limits you to one way of thinking. Sometimes you need to push your mind to think about other programming paradigms, which is why I tried picking up Elixir, I tried picking up Golang, I tried picking up Erlang, I tried picking up Haskell. I tried all these languages and I kept gravitating back towards Rust. I kept thinking something in the back of my head, which told me several years ago, around 8 years ago, I was wondering whether I should pick up Python or Ruby. And for some reason, I kept thinking maybe Python was the right answer. And I asked a close friend, and he agreed with me. He said, you should definitely look at Python instead of Ruby. And that's it. That was the choice I made. I stuck with it. Similarly, that's the kind of choice I'm making right now. Rust seems like the logical direction for me, and I'm gravitating towards it. Now, why would I learn Rust? Shipping Python applications subjectively is getting quite hard. I remember 8 years ago when I didn't know much about programming language. All I did was I used a Windows machine back then for work, and all I did was install Python 2.7. I did not know anything about virtual environments. I knew nothing. I installed it as an administrator. I installed the libraries I needed. I wrote some PyQt applications. I've later created installers using PyInstaller with, and then installed those in other machines wherever I needed to get it running. And that was it. While that was not a that was not the right way of working, but I got the job done, which is important. Lately, you can still do that, but you slowly start approaching a paradox of choice. You have many ways of doing the same thing, which is quite odd because there should be one and only one quite obvious way of doing it, according to this Python. But you choice is not bad, but when you start overwhelming a lot of newcomers into the language with choice, you start getting this problem. So if you want to set up your Python environment, and I have done this for years now, I used to use Miniconda. Miniconda, for those of you who know, is a smaller version, it's a stripped down version of Anaconda. What it does is it gives you only very few libraries, it's the built-ins, along with the conda command. The conda command allows you to install different versions of Python. It allows you to do some dependency management and use it instead of pip. And it also allows you to install non-Python dependencies. Like you can say conda install npm into your specific conda environment. It's quite useful. But I soon started seeing different problems. I started seeing problems with respect to my editor, for example. I use NeoVim, and my language server was unable to detect the right version of the environment. I started running into these problems further and further. I later switched over to using Poetry for my, at least for my Python modules, and I've been fairly happy with it. Poetry makes things much, much easier, and I liked it. However, coming back to the problem of virtual environments and Python installations, I was not very happy even with how Poetry did. So what I started doing was I started compiling Python myself. Started getting different versions of Python, compiling them, and creating virtual environments manually for a project and saving them to a specific folder. I know you have libraries like PyEnv and virtually wrapper which can do the same, but I was not very happy with how they did it. Maybe it was just my own way of working. I just wanted to be in control of my environments. I wanted to be explicit as to what I was doing. And then I also ran into a problem of shipping binaries. While PyInstaller did work a long time ago, and while it does still work to some extent, what PyInstaller does is let's it's like saying if you want the cake, it gives you the bakery. It gives you the entire Python environment. It gives you dependent the entire Python interpreter. It ships the entire thing as one single file, and while that might work, it's still too much bloat. It's way too much. And shipping this again and again is not really. It's an interpreted language, right? You get you get the limitations and the powers of an language. It's fine. But no insult to Python there. It's one of the best languages I've ever worked with, and it is fairly. It gives you a fair developer experience, right? But I wanted something more. I wanted to understand how you would build if you had to recreate a language from scratch, for example. You had to rethink how a modern language, what are the changes that they would, if Python was made today, what are the changes? What are the changes that some of that Python is getting lately? Some of these changes are inspired, by the way, by Node.js. Some of these are inspired by other languages like Prolog. And you reach a point where you start thinking, is there something better? And you would want to experiment with different paradigms. And someone who's self-taught, Python doesn't teach you, it abstracts away a lot of stuff that's happening under the hood. It abstracts everything away. And what it does is it doesn't teach you about memory management, for example. You're told from the start that you're not supposed to use threads because really threads are limited by the global interpreter lock, the GIL. And if you also want to understand how to truly implement a thread safe or a truly safe multi-threaded application, how do you do that? You cannot do that. At least not easily without a third-party memory store. You would definitely need to have something that is external, like memcached or Redis, and then you would have to use that to manage your shared memory space. And then on top of all of that, you don't understand how memory truly works. You don't understand how the entire it because it hides a lot of this thing away from you. While it helps you to get the job done. It also gives you the limitation that you cannot learn some of these things as a developer, and you would need to turn to other ways, or you would need to dig under the hood. You would need to understand more and more of what is happening. So yeah, and Rust lets you do these things. When you learn a lower level language, Rust gives you the power to do these things. It gives you the simplicity of a high level language like Python, and it also gives you a way to become a better programmer. It's about safe concurrence, about simpler solution to multi-threaded applications, to multi-processing applications. And ultimately, it gives you a way of becoming a far better developer, which I will explain later. So you might also ask yourself, why not Golang? Why not Java? Why not C? Why not C? And my answer to that, as it has been already, is just follow your instinct. Learn what you want to. Because sometimes you need to just follow your gut. At the same time, maybe you want some numbers. So the Debian project, what it does is it has a benchmark scheme. You can use the benchmarks, you can see the output of the benchmark scheme, what uh, the performance numbers are of different languages. And while the project itself tells you that you should not blindly follow benchmarking numbers because you have to use the right tool at the right place, it might be of some interest to some viewers. And um, another thing, like Rust comes with something from the outset called the borrow checker, and it has a concept called ownership, which I will get into later. Those are really interesting when you get into it. While it is not enough for me to recommend a language just because it has this nifty feature, I would also say that ownership and borrowing is really, really interesting to me personally. And by the way, if you have ever compiled a Rust program, you will be amazed at how small the binary is. You get the job done with, I can write a web server which is 6 MB inside, even lower. And that in today's day and age is insanely. And finally, Rust comes with one of the best package managers, environment managers, uh, testing tools, whatever you want to call it. Cargo is the most amazing package manager I've ever seen. It takes inspiration from the best of NPM. It takes inspiration from Ruby's own gem manager. It takes all of that and it gives you something really, really amazing. So yeah, let's dive in. So what does Rust look like? It looks like this. As a Pythonista, the first thing that hits you is, okay, fn is an alias for def, clearly. I have a main function, sure. I have parentheses. And second line is something that says print line, exclamation mark, and there is string. While I'm trying to hold back, this is not a string, but consider it to be a string for now. And then you have a semicolon. Right? You have, this is Rust. This is your hello world. What it says Namaskara, BangPypers. Namaskara, the first word of the sentence, is hello in my local language, Kannada, which is spoken in Bangalore. So what this gives you is, it just prints this out. And for those of you viewing, you will get a link to the repository towards the end of this talk, and it gives you the same thing. It gives you a way running my examples. It is a part of my blog. It's in my blog's repository. It's inside one of the subfolders, and I've linked the absolute path for you. But what you can do is, you can say cargo run -n, and it will run the first exercise, which prints out this. You can follow along and you can learn how to use this tool by saying cargo run --please --help, and it will tell you how to use this tool. And to install, I have skimmed over, I have not spoken about how to install Rust, which is something you should probably Google and install. The best way to install Rust is to install something called Rust Up, which you can find online. Now, what does real code look like? This is so-called real. This is a code snippet that I've taken from one of the best Rust learning resources out there. It's called Rust Links, and this is one of their examples on how to learn functions. So I've added some of these comments myself. This gives you 3 functions. One is a main function, as we saw before. We have a let keeper, fine. It looks very similar to JavaScript or something. And then you have a variable name, and you have an equal to, and it says 51, fine. And you have again your print statement. For some odd reason, you will start realizing the exclamation mark. And then again, you have a string formatter. And here you're calling a function, which is defined later. So function. And here, this function starts, here's where the fun starts. Some of you might know that Python also has type hints now, and you can use type hints which look somewhat similar. So you say price, i32 integer, 32-bit integer, and this returns a bit integer. So, and inside this function, you have an if statement which calls another function, passes the price to it, and then returns price minus 10 and price minus 3, depending on whether it is even or odd. And then you have the same function here. So same thing happens here. Ignore the logic for now, but just notice something strange about these 3. While each of these lines has ended with a semicolon, these lines do not. The reason is, anything in Rust which does not have a semicolon is interpreted as a return statement. This returns its value outwards. Since it is called in the function and there is nothing for it, it takes this, it runs this piece of code and returns this. You can also choose to use the return method, but you don't need to, unless you have some part of your code where you want to jump out of it. Let's say you have a function where you jump out of your function 3 lines into the function, depending on something. Just say return and give it a value. But when you use a return keyword, you need to use the semicolon. Let me show you. loading examples, and there you go. So as you see here, this is the same thing that you saw in the example before, except instead of price minus 10, I've said return price minus 10. I have a semicolon. The moment I remove this semicolon, Rust is going to tell me that there is an error here, that I need a semicolon when I compile. So now there are other things in this code that you need to understand. There are other things here that you should probably there are other things in this code that you should be. One of them is this. These are comments in Rust. These are all comments in Rust. However, there is a difference between these kind of comments and these kind of. This is a file level documentation. It's like a module level doc string in Python. And this is a function doc string, the triple backslash. Rust does not have multi-line commits. You can create a multi-line string if you want and call it a commit, but again, what it does have is these, you use a double backslash like in normal language to have a normal inline comment. But let's say you want to have a function level comment, function level doc string. Then you use a triple backslash, and that's how you get the doc string. This doc string is attached to this. By the way, I made a mistake. So even if you use the return keyword, you don't need a semicolon. It's just at this point it's not necessary. I assumed it was necessary. That was my mistake. It still compiles. One nice way of checking whether your code compiles is saying cargo check. It tells you instantly. If I had something here, now if I put a semicolon here, instantly it tells me that I need to remove the semicolon. It would have told me the same thing if I said cargo check. This. And it also tells you exactly what to do. This is one of the nice things about it. The compiler teaches you how to write Rust code. So I do this, and I can put a return statement. Interesting. So now more code. This is more Rust code, again from another Rust links example. And you do not need to understand any of this, right? You have something called hash derive. And if you take a clear look, these are duller colors. These are like, it's like as if the UI is disabled, for example. So this indicates that it is not a comment. This is definitely a comment. This is something that you will learn eventually. You do not need to be worried about what these are for now. You can choose to ignore them, but for now, all you need to know is this: the hash, the pound symbol, is not a comment. There is only one type of comment, which is the double back. And depending on what the third character is, the nature of the comment changes. Right? Now, so Rust code follows something very, very interesting. Like you don't have objects exactly. You have structs, which you might have seen in class or even Go. And you also have something called traits. The way these work is you give your Rust code additional, you give it of behaving different. You give them, you give objects new methods, so to speak. But you can compose your methods based on these traits. Some languages also call them interfaces. You might have seen them in JavaScript. So you can compose object of different kinds of interfaces or traits, and you can give it different methods. These grouped interfaces, grouped traits, give you different ways of behaving. You will see more of these. So, Rust memory management. This is something very interesting. And if you've written, say, Python code, it behaves sort of similar. You have a value x10, and inside parentheses, you start a new scope. And inside this, you also assign a 15 to x, and you try to print the value. You reassign x to 18, you print the value again, and then you print the value outside of the scope. This is the same example. Let's try running this. Example number 4, so I'm running that, and yes, it prints 15, 18, and 10 as you did, because it printed this first 15, 18, and outside it's back to the original value. Now there is something here that you may have noticed. This version has something called mute. It has just one word, MUT, while this does not. Let's see what happens if I remove this. The moment I remove this, Rust tells me that I cannot assign twice to an immutable variable. And it tells me that I should consider making this binding mutable. It says I should change this to mute, and only then can I change. What if I change it here? And then it tells me that I have to remove this mute. Why? Say cargo check. It says there is an unused mute. I'm making this binding. This assignment is called a binding the value 10 to x. And what I'm doing here is I'm saying, hey, I want this to be mutable. I want this to be changeable in the. But Rust is saying, all right, I am doing that, but I'm warning you that you're not changing your value. So you don't need it to be mutable. So delete it. Unless, of course, I change it later. If I say, I come down and I say, and I print this now. Finally, it doesn't complain. It does not complain. It changes the value, which is how Rust works essentially. In Rust, every single binding, every single assignment by default is immutable. If you want it to be mutable, you have to explicitly state that it is a mutable value. It is a mutable binding. So now, if you want to move a value, so this is another concept that you have in Rust. Rust has something called movement. You can move variables around. You can move binding. So take this for example. You have a code snippet. I have something called x, which is string with a capital S. Ignore this for now. And it says hello.toString. Again, ignore this. And I print the value here. And then I say y is equal to x. Great. This is normal, just how I would do it in Python. And then I try to print this. Fine, that works. Look at this part. I've commented this out, and you will see other snippets like this. I've done this so that you do not see errors when you're trying to run the first. But you can uncomment it to see what you would get. And instantly, it tells me that there is something here that is an error. In red, it is an error, and in green, it is a tip. So what it is saying is, borrow of move value x, borrowed here after move. Let's try seeing what the error actually is. So it's saying that this x value borrowed here to move. The value was moved here, and the move occurs because x has a type string which does not implement the copy trait. I don't know what any of this means. All I know is that x moved. What is this movement called? What does that movement mean? In Rust, when you assign something like this, the value is not copied by default. It is moved, as in x held the binding to this string value. X held this binding. Able to print it. Now I'm saying y has taken that. This value, whatever x was pointing to, moved into y. Now x has nothing. X is not pointing to anything. X does not own anything. So, and then I'm able to print y. But the moment I come here, it says, sorry, I can't let you do that. All right, that is fine. But now let's try something else. I'm going to print an integer value. I'm going to print an integer value. Now I'm going to say is equal to, and I'm going to try this. This is essentially the same. String formatting in Rust is very similar to Python. I could have said this instead of this, one of two ways. So try this or that. Right? So this is the code. So I'm trying to run this, and it runs. It said z is equal to 10, u is equal to 10, which is strange. What just happened here? I've done the same thing, but instead the data type is different. This data type saying, okay, it's a string. Here, I'm not saying what this data type is. Okay, so let me try doing it. I'm going to call this an 8-bit integer. And well, there is no difference. Exactly the same. What just happened here? Remember the error you got before? This error said X has type string, which does not implement the copy trait. And it says the value has been moved here. This copy trait is what we will see more of later. Trait is an ability. This data type does not have the ability to be copied. It is not implemented. But integers by default have that ability. Integers can be copied over. So when you say this, for example, u is equal to z, this value is being copied. It's not being moved. It's still there. Which is why we can use it again. We can use this again because it has not been moved. It has been copied. Let's say now I'm changing this value. It's just been copied. It's not been changed. This value has not been changed. U was just a copy of what Z had, which was I changed this value, and now Z is still preserved. This is exactly what I wanted. I did not want Z to be copied over and then changed completely. Why didn't it implement that with strings? This is something you will get to later. Rust does not do things unless you ask it. It does not do non-obvious things. Because if you think they are obvious and you ask it to implement it by default, sometimes you will be surprised and it might not be a very happy surprise. So Rust's entire memory model is centered around ownership and borrowing. This is just more of these errors, but you can go through these links to understand what is happening. The Rust analyzer, which is how Rust, my editor, is able to understand what's happening here as I'm typing and saving the file, tells me that we can't use the value of X because it has moved. And it also tells us that string does not implement the copy trait. As I said, traits are abilities. They're abilities that types and structs have in Rust. You can implement a trait on any data type, give it that ability. Some traits are installable. You can use the hash derived syntax, which you saw earlier, to implement a trait. Remember the word, by the way. Implement is exactly what you do when you have a trait that you want to give some new struct or a new data type. You can also override traits. You can make your data types have some not so obvious features. How do you subtract a string from another string? Would implement that, for example. Or let's say you create a new point. You create a new data type which is geometrical pointed, or point on a two-dimensional plane, by for example. How do you add or how do you subtract a point from another point? Even though that is quite meaningless. Let's say we are going to use the subtraction operator to give us the distance between. Now that somehow makes sense. Assume it does. And all we need to do then is use the minus operator and implement it that way. It's exactly the same as using the underscore sub, the dunder sub magic method. You could subtract one from the other. You could subtract self from the other, and the other from the self. The order is for implementation. That's how it works. So, and you can also do something like, while I'm saying that it is very similar to the dunder methods, it is a very strong trivialization of what traits actually. Remember that traits are very much interfaces. It's interface driven development. It's not exactly object oriented. There is no exact inheritance. So as long as something has a trait, you can use it, or you can use it in a way that that trait is meant to be used. We'll see more of this later. Now, what is borrowing? What does this borrowing mean? Now look at this example. You have two functions: borrow a string, move a string. This takes an input x, which uses this symbol, the ampersand, says str, fine, and it prints out I've only borrowed a string. Value is the value. And also you have one more method, one more function, move a string. X is a string with a capital S again, and it says print line. I've taken an ownership of value is inside. Now in the main function, create a string. This is a new syntax of create. Before I was using .toString. I'll explain what strings exactly are later. Well, you create this, and then you pass it to do these two functions. The first function, you use ampersand. The second function, not. This line will give you an error. Does this work? Look at this. So, ampersand is what you use to pass a reference. If you do not use this, your editor is going to tell you, as it tells me, that I have to use it. All right. And run x tells me, it just prints this out. It tells me that I'm only borrowing, and the value is this. I've taken ownership of string. Value is this. You know, this is just my normal string format. Now let's try doing this. This gives me the same error that it gives. Back tells me that this value borrowed here to move, the value was moved here, and this move occurs because it has type string, which does not implement the copy trait. Again, it is just telling me that B does not have the ability to be copied. It has the ability to be moved, because you never told me how to copy a string. You just said this is a function which moves, which takes the ownership of it. It moves it. That's it. You do not have it again. Fine. Mutable borrow. While you had this here, you could not do something like x.push and give it a character. If you tried this, it tells me I have to, oh, by the way, yeah, Rust has just different, some other languages too, which was very odd to me as Pythonist. Double quotes do not mean the same thing as single quote. If you use a single quote, it is very different to a single quote is a character, a double quote is a string. So if you want just one character, only a character, you need to use single quote. You want a string, you use double quotes. So here I need only a single, because I'm trying to push one character to this string. But now it's saying that it cannot borrow x as a mutable because it is not declared as a mutable. It cannot borrow it. Let me say it's a mutable string. But again, it says it cannot find a value. And here it says it is mutable. So now it does it. It is able to do it. Because it has taken and it is declaring itself to be immutable. Let's try looking at the next example. Brings what is happening here. Sometimes I don't want to move an object and have it be mutable reference to be. As in, I have a vector inverse, by the way, a list, Python, an array, so this is a vector of integer value of exactly of unsigned 32-bit integers, because all of them are positive. This example will break the moment I add a minus a negative value. The moment I add this, this says the trait negative is not implemented for this. How does it know that it is supposed to be this type? Because I'm passing it to this function, which makes that assumption for us. So if I forced it to be, if I passed it to be this, that was weird. If I had said that this is an I32 instead, it would instantly complain saying a mismatch types, because this required a U32, but I'm saying that this is an I32. So back to this. So it's saying that this requires an unsigned 32, a vector, array. So I'm passing this, and I say I'll go check. I'll go hyphen 7, and it does it. What it does is it takes this vector, mutable, and it passes it to this vector, passes it to this function, and inside this function changes the value. It adds a single integer value to it, adds a single unsigned integer. Of course, I gave it, and it prints this out. And this is how I get the value. See here that this returns nothing, just modifies it. It modifies this why it has a semicolon, and it is also why it doesn't have an arrow mark. It tells us that this is being that this returns something. It does not return anything at all. Definitely better than it. Now, this there's one more thing to see here. And see this. This is printing the debug value x, because x is a vector. It does not really have a string. So if you just try using curly braces, it would have tried printing out the string representation. Not so obvious. Then you say, hey, if this has a debug or a or a or a development representation with it, in that instance, that's all I need, and that's what it is. In Python, this would have been very similar to your repr method inside something. So moving on, strings and Rust are very different. The way they work, you need to think a lot about strings to be. This video is something which was recommended to me when I was first learning Rust, and I thoroughly recommend. And the official documentation, which goes into how strings are represented, because they're all UTF encoded. They're not ASCII. The reason you need to understand this example is because this is a very non-trivial problem. Consider this, by the way. Consider this, by the way. The Namaskara word is represented like this. You would think that it is 1, 2, 3, 4 characters, or at the most, maybe this is a 5th character, 5. However, let's say you want to pop out the 4th or the 2nd character. In normal Python, it would be like you would think 0, 1, 2. So give me the second, give me the index of 1, the 2nd character. I would get this character, which is not true. This is not represented as just 4 or 5 or even 6 characters. Represented as a lot more inside. You try converting this to bytes. Try converting this to bytes. This is how many you get. This is more than 20. These are more than 20 bytes. And then let's say, all right, fine, I don't care what the bytes are. Give me the individual letters as they are represented in language, which is another rabbit hole, by the way. You split this into the so-called individual letters. And by the way, while I'm highlighting it in my editor, in my terminal, I'm already seeing some differences. Strange characters here. I highlight them, which is what I get here. I get these characters. There's something in between /u, ccd, and then there is this, and then this, which is represented with some kind of a symbol, and it's so many characters. Now tell me, if you want the second character, might be very obvious, but what about the fourth? What are you going to give me when I say I want the fourth character? This is, or is it this? It's not obvious, which is why Rust does the only same thing you handle it. You figure out what that, which is why what it does is it gives you direct access to what the string is, and it gives you ways to get them as characters, or even get the graphemes, which is more than I knew about UTF-8 a month ago. I will go more into strings later, but let's go back to traits. What is a trait? Remember how I said trait? Ability. Step 1. Yeah. Let's go to strings first. We'll go back to strings first. So one of the best ways to understand what strings are and how they're used is to look at this quiz for it. This is in Rust Links, the interactive course that I was talking about, which I will link to my slides. This course also gives you one of the quizzes it gives you is for strings, which is quiz number 2. It gives you 2 functions. It takes address of str or a reference to. Don't call it address of. This is how I used to intone it in my head, because that's how I was taught when I was learning C in high school. We had C in high school for a very short time. So this is how I sort of understood what it was, and I was wrong. This is a reference to. You're passing a reference R, whatever that is. And then you have something which takes a string, so to speak. And this is how you start using it. The first one uses string slice. The second one is a string. Third one is a string. Fourth is string. And then again in the middle you have string slice twice. How do you differentiate each of them? Now this, as I've been telling you before, something which just double quotes is called a string slice. This is a pure string slice. It is not exact. It is sort of like a reference to something within a string. For example, this exists as a string, but it is not exactly a string. So this is just a slice of a string, like a slice of an. This gives you a proper string object of definitive size. This entire thing has a known size at compile time, and this we know exactly what it is. It is a string which has the value read. And you can also create it like this. You can choose to do this, or you can choose to say string : this is how you access a method inside a. Excuse me. This is how you access a method from access a function from within a library. So you say string from, you create it from this string slice, or you also say this. You have a string slice and you say to owned, or you let Rust do it for you. Many data types have a method called into, which essentially guesses what you need to convert it into. Say this and just say into, and it'll convert it as depending on the signature of this function, wherever this function is. It takes a look at this function, goes like, all right, I need a string. Can I convert this into a string object? Yeah, because it's a string slice. I will do that. Or you use the format. Well, I'm not going to tell you what this is yet. So you use the format function, and it gives that to you, the normal string format. And how do you do that for string slice? You can say you have ABC, you create a string from that, and then you take a slice of this, can be, and you pass a reference. This is how you take a slice of vector of anything which looks like anything which looks like a vector. You give it the starting element and the end, and it creates it. So it just gives you A, by the way. It's this. So next, you take the strings in a string slice, and you do this same thing, and then finally you can also say toString, and you can also do stuff like replacing something with, and you have other methods. All of these are documented within Rust document with string method functions. Learn how to do all of this. This example, along with the entirety of Rust, the Rustling course, is something I would recommend for anyone who should start off your journey by reading a tutorial on Rust, and then try jumping into this as you're writing code on the side, as you're trying to do different things. Helps you. Now, now, traits. What are traits? Like I've been saying, traits are abilities. And what they do is you can define something. This is an ability. A trait can exist independently of a class, of a struct. You do not need to have a struct in order to have a trait. You can have a library which is just traits, but you don't have any implementations of it. But they're most powerful when you use them. So in this example, I created called can wave. This is a trait which says, all right, I have something which can. In it, I need two methods. One gives me the name of this. Other waves actually does the waving part. So if you have an adult human, they have this is a struct. They have an attribute called name, which is and I'm implementing. Impl means I'm going to implement this trait for. So I'm making sure that the adult can wave. I have to match the signature. That same. I have get name just written. See that it when it says it returns a reference to R, it returns string slice, and then you have v, which takes itself in Python. It's very similar to what Python itself does, but instead of passing ownership, you pass a reference to it because you don't want your object to vanish the moment you use this method. Because if you say just self, that's it. Your entire object has moved into its own method, and you can't get out. Actually, I'm pretty curious of what happens when give you that. So it tells me that it expects a lifetime parameter. Yeah, I'm not going to get into any of this. I was just out of curiosity. So this is how you implement it for an adult. And ignore the get name method. All you need to look at is the wave. So it creates a string and says it is from. Is I give. This is how an adult wave, so to speak. And then I have a child. The child also can wave. This is what they do. At the same time, this continues. I have a trained dog, and that dog can also barks. And but then I also have another dog which we never bothered to train. Never taught it how to. No one ever taught it how to wave. So this dog does not implement this. And now, the reason we went through all of this is this function here. This function this function takes something which is a reference to something which implements can wave. All it does is tell me whether it is whether it's a dog or a trained dog or a child, whatever you all it tells me, give me something that implements this trait. And then it calls the function associated. How do I know that these functions are there? Because the trait definition tells me functions exist. I call it. The moment I say I call these functions, the moment I call these, I create these objects. I can use these function objects, the function, to use these. And it says, hey, it returns, it keeps working. But let's try to run this for the dog which never got a train. And immediately, okay, the first problem I need to solve is that I need a reference, not the app. And then it gives me an error. What's the error? It tells me that this object does not implement the can wave trait because it is required by a bound introduced in the call. This call has a function, has a requirement that needs to implement, which it did not implement. So that is why the moment we try to do, compiler immediately tells us that it is not allowed to do so. So that's more or less it about. That's more or less what I wanted to talk to you about. You can also learn more about cargo, saying cargo help. One of the neat commands is clean, which cleans up your end, moves everything you have in. But you can also when you do cargo clean, it deletes all the dependencies. So you try cargo check again, it will try to recompile everything, which might take a while. There are a lot of jokes about how long Rust compilation, but it is getting. So after compiling, you can see that you have a target folder. Target folder has a subfolder, and this has build folder, has more. You will have a lot of files with this. It gets a lot of the dependency and it builds all of it. But you say cargo build. Say cargo build builds your entire code, gives you one single binary, a binary which you can use wherever. So have this. This is your binary. That's everything. Check. It's 4.1 MB. All the dependencies. Now, what? Let's say you want to clean this up. Target folder. Now, let's understand how the modules. Cargo module system. Very many ways, it's very similar to how Python does. It might not look like that from the out, but it is very, at least to me. So this is my folder, my project folder. These are all the files I have. Cargo lock file, a cargo toml file, the readme. There's an src folder, and which has a subfolder called examples, and it has all along with a rs. There is a lib.rs and main.rs. Let's go through each one. Cargo in the toml file, essentially, your project definition file. It tells me what the project is, what the version, which edition of Rust I'm using, and what the dependencies. So where these are your main dependencies. This does not tell you what these themselves depend. That's where the cargo lock file. Cargo lock file is another toml file which has a list of all the dependencies. You don't need to manually tells you right out of the box that you can't be in. Has checksums of each of them. Tells you where to download it. So For those two dependencies, I have around 241 lines, 41 lines of code here, which does not really reflect anything. It just talks about how many dependencies. But this is something very nice to have, since all your dependencies given their checksum. So you get security right out of the box. You can verify that this is the same installation I had a week ago. So these are these two files. Now let's check out the src. src folder has a lib.r, main.r. So main.rs is your entry point. Ignore all of this code. You do not need to understand any of this. Just these are like your Python imports. You're importing these, and you'll be able to use whatever. Just like how you saw, this is the one thing that you should look at. They use Rust for Python. The name of this library, this entire. Each Rust project is called a crate. So this is the name of that crate. So this is a submodule within it. There is examples, and then this calls a function within. Each of these examples have a run file, a run function, and this is how you call it. Don't focus too much on this right now. So how do I know that this is a library? How do I know where is this example file? This is how I know. The lib.rs, I declare that there is a module called example, that it is public. That something outside of this file can import it. .rs knows that there is a because the lib.rs says so. And how does the lib.rs even know that there are submodules within the example? This is how the mod.rs file, Rust module, is something like the dunder init file inside a Python. In each sublevel, each subfolder, have a mod.rs which declares all the modules which are inside it. One example. And each of these in turn don't really say anything, except they only say what functions. So as you were looking from the beginning, it just there is a, and remember that if you want to use something else, you have to say that it's public. If I remove the word public, I will not be able to import it outside of that scope. So that's how Rust preserves the private and public methods. You can go into something a little more complex, something which has these. Look at these. These two are private functions. This is a public function. Are these two private? Because they're only used within this module. They're only used within this file. However, this function is being called in your main.r, which is why I made it public. That's it, essentially. You can also choose to write your tests, and in most cases, people just write tests within your. So they just mark a module called test within the same file, and that's how they write. That's how they test Rust code, which is really fine. So, how does Rust? One of the things I learned the most about Rust is types. Types help me understand a lot of code. They help me understand what it makes me think a lot. Like one of the things I ran into, I was trying to extract data from a database, extract a number, and my code constantly assumed that it's 32. And one of the values that I got from one table, different database, 64-bit. And I never accounted for that. If it had been Python, Python would have just been, right, this is a number. That's it. It would have abstracted everything. However, Rust failed. Just told me that, hey, you cannot run this because you expected a 32-bit integer and you got a 6. That's not acceptable. That really, and it also helped me understand some design flaw. So I'm really grateful for interface-oriented programming. Really a different time from how you have object-oriented. You could do the same thing like you saw here. You could do this in Python, but it would be much more work. You would have to check matters of every object you passed in, because the type is just a suggestion and it's not really at runtime. And while you check the address, you would have to see that it has get name, and you would have to be able to check. You would never know whether they actually return string. They could be returning nothing, for example. But here you do know. The way you know is this function in turn has to return a string because now the trait said it. Also, these two things expect strings or slices. The formatting placeholders, they expect strings. Why? You need string. You have to get string because it if neither of these returns something which could be represented as a string, it returned a struct, or if it returned something else, for example, function, then it would have said, hey, I don't know how to display this because it does not have a display trait. Display is like dunder in Python, so it does the string representations of it. So just you a lot of these. And another thing is, I've never really thought about how my variables move in an having control of where your variables move and where they're mutable versus immutable gives you a way of understanding how code very natively. It helps you understand how code is so is like an instruction. It is essentially an instruction, right? It helps you understand how code becomes so powerful, especially because you're controlling everything about it. If you don't know where your code is mutable versus immutable, for example, in Python, a lot of people don't realize pass a list into a function. That list is a mutable reference to the original list. And if you modify it within the function, the original list gets modified. In such cases, probably be passing a tuple instead. If you don't want it changed, even by somebody else's code, or even if it is your pass a tuple instead. It is just meant to be consumed there. Another way to do it is pass a copy of your list, but then you're doubling your memory. You don't need to do that. Pass a tuple and you know tuple is. So people just use lists everywhere. I have just used lists, and only now do I probably be using tuples instead. And you also have and a lot of things about what you write. Let's have a function which returns some enum or which consumes an enum, and I only account for two variants of that. But in Rust, you will need to account for everything, or you will need to have some kind of a placeholder which says, "Hey, if it's anything else, do this." If you don't have that, Rust immediately starts complaining, like, "Hey, I have three variants of this enum. You only accounted for two. There is a third one. What do I do with it?" And or let's say you had an enum which originally had only four variants, and you've accounted for all those four variants in your function somewhere. However, let's say you have somebody goes around and adds a new enum variant, that same enum. Immediately your code breaks, saying, "Hey, you have a new variant, not accounted for it," which is brilliant. Exactly how code should be. And this goes the same way for errors, but because errors in Rust are essentially enums. They're just varieties of the same thing which implements certain traits. They're just everything boils down to that fact, and you need to match whether it does this or whether it does. It's just so beautiful in that. And you also mark some functions saying, "Hey, you want to return some," and you have to use. You cannot ignore what the return of my state or what the return of my execution is, and that's very important. Sometimes you might have a function calls an API, and the developer might have put in something saying success is equal to true or false. It returns a true, your API call was a success. If false, your API was a failure, and you will need to account for what happens. I myself have been guilty of situations where I've been like, I've sent out the request, I'm not bothered understanding what happened afterwards. You need to catch it and examine the status code to understand whether your request was actually sent or not sent, or you might as well not send it. So these are links to certain things, questions that you might have. All right, I'm going to learn Rust. How do I make a GUI? How do I CLI? How do I write code? Connect to a database, connect to a game. Maybe you want to write linked lists. Maybe you want to create a web application. Do you want to connect to the Ethereum blockchain? Do you want to configure your IP? Do you want to write asynchronous code? Do you want to write ASM code? Or maybe you want to start learning, which is the Rust book. I've just linked to the Rust book. So one of the best resources to use. So the resources I recommend are the Rust book. This section of CS 4414, which is a course on operating systems, but it uses Rust. You don't need to go through the course. If you want to, you can. I'm not gone through it. The reason I came across it was I was searching for reasons to use Rust for this presentation. And this had a very, very detailed explanation how you would learn Rust in C or C++. I'm not recommending you do that. I recommend a lot of people start with C. If you ever have a chance to learn, you should learn C. But at the same time, Rust is a great example of language could use in a course like this. This article, this article is one of the best articles on learning Rust, at least the base syntax. It while it says half hour, if you're going to type out each every line of the examples, it will take you about 45 minutes to 2 hours, depending on how fast you type and how much time you spend on code. So your mileage may be. What I would recommend is going through this article and then trying the Rustling sizes. And remember, with Rustlings, you might want to like Google for advice or solutions. I had to do it once or twice, and then I went back and tried to understand what was. The string video I recommended earlier was from the Let's Get Rusty channel. He also goes through the entire Rustlang book, and these are videos of him doing that. The Rust in Action book, which is published by Manning, is pretty amazing. John Jengset's book Rust for Rustaceans is amazing, and so is his YouTube channel. John is one of the best intermediate to advanced level YouTube content creator I've ever seen, and that space is always very, very hard to find content for when you're learning. Zero to Prod is also a really good book. It's just released, so you're pretty sure you can find a discount coupon online or maybe get it for a really good price. I think there is some Indian pricing for this. So this is really good. And the last link is a bunch of the code from this presentation, all the code that you've, all the code you're seeing here. So you can go through that, and yeah. So that's it for me. As an end note, I would like to say that while learning languages should be like it's like an experience, right? You learn languages not so that you can start switching over. Maybe you got bored of one language, and that's not a bad reason to learn a language. But at the end of the day, you should probably be one of the reasons why you should be learning a language is also to try understand different paradigms. Try learning new paradigms of coding, new paradigms of approaching problems, and you can also get to a point wherein you start realizing that your base language had all the tools that you need, but maybe you got a new paradigm which helped you think in a different approach a problem. One of the things, so in the 30 days that I've been using Rust, I've been able to create two things. One of them is a CLI for this presentation. This entire presentation uses a CLI which I wrote over an evening before the presentation started. It wasn't very hard to create. It was just I just had to use some traits which somebody had already created, and I had to just get some parameters. And the other thing I made was something for work. I work at Mutable, hiring by the way, and the thing I made for them was we wanted to profile to run checks against our databases, see, and to also understand how much time. So I figured Rust was always the best thing to do because it doesn't add any overhead. This was a web API. I used Rocket, which is finally running on stable Rust. By the way, a lot of the old content regarding Rocket will tell you that it runs on the nightly or the unstable version of Rust, which is no longer true. The latest release uses the stable versions of Rust, and fascinating. It's really a good time to be a Rust user. Rocket, by the way, is extremely similar to Flask, which is how I got started with programming. So I felt strongly. Yeah, it was fun to build. Thank you so much. Have a great day.